Hello, Phil here again. Welcome back. This is week 2. I'm going to talk about teaching trigonometry this week. So I hope you enjoy what's going to happen. I know, as I said last week, that we're going to we'll focus on, this pedagogy. How am I going to teach trigonometry to kids so that they understand or deep understanding of what we're talking about in the senior trigonometry? So let's move on. So what we're going to do this week is look at unit circle and the derivation of the sine and the cosine rules. Hopefully this is a bit hands-on and meaningful for you. It might challenge you a little bit. We'll see how we go. That's what I want to do. Just a quick review of middle school trigonometry and understand how we can sketch trig functions. You can read it, what we've got to do this week. So let's start off with, we need to review the middle school trigonometry, and basically it's not just sine, cos and tan. Pythagoras also, but also in the 10A course of study, we also now do in year 10, which we haven't done in the past, is sine rule, cosine rule. Pythag in 3D, there's also the opportunity to do unit circle. Now here's not to say that all the students in you're going to have in the year 11 class would have done all of those. But I mean, you might also find out there'll be kids new to your school that have come from other schools, feeder schools, that changing schools, for whatever reason they do that, they may have in fact done this before, they may not have done this before. We also just need to understand that in the 10A course of the study, where you do those sine rule, cosine rule, etc., there's no requirement anywhere for a student who does general maths in year 10 can't do maths methods or specialist in year 11 and 12. Just be careful of your legal requirements there, what you can and can't do. So what I'd be looking to do to start with again is rather than just give them a whole set of questions saying, find the sine of this and the cosine of that, maybe start with the question, what can you tell me about this triangle? And see if we can, get from the students how they can articulate what they understand about that triangle there. We know that, the sine of angle, whatever it is, and look at Pythagoras rule. Get them to delve in what their prior knowledge is, and without that prior knowledge, the rest of what we do in this unit is underpinned by that. So, good open-ended question. What can you tell me? You could even put in, instead of there, you can put in an angle, or you can put in, say, two sides, if you want to get numeric with it, rather than looking at it from an abstract point of view. Personally, I probably would start with some numbers, but it's up to you. But again, I would get the kids to articulate what their understanding is. You get a lot more guide as to what they can and can't do, rather than get them to do a number of questions, because that means they can only do those questions, if you know what I mean. So let's start with Unit 2 in Maths Methods. You can see there it's topic 3 and the starting of this, and you can see that it's got 9 hours of study across 2 subtopics. So the first one's about circular measure, and the other one's about introducing the graphs of sine, cos and tan graphs. Also unit circle stuff on understanding the unit circle from the sine, cos and tan exact values, etc. And so you can see there, would I do that in 9 hours straight? You're looking at 9 hours. If you did that straight, you're looking at maybe, getting on to 2.5 weeks of study. Would you do that all in one go? So how do we actually understand what a radian is? Again, look, seriously, you can stand in front of a class and tell them and get them to draw and write, this is a radian. So what we're going to do in the tutorial this week is have a look at how we might use a hands-on approach to that. And you would, you can look up on YouTube all the different ways. I know that I went to a conference and was shown this rather than I looked it up on YouTube, because I don't think YouTube was actually around in those days. And I go to Coles or Woolies and buy a stack of dinner-sized paper plates, and we talk about radians and unit circle and stuff. in reality, what I really do for radian measure, I clear the classroom and we do an activity on the floor with paper cups and stuff, and that's how I do it, with a very much a big hands-on approach. And it's amazing the dynamic conversations that happen as a result of this. And in my tutorial, I'm sure Ben and his are going to go through that same thing. How do we develop this idea of a radian measure? When I was talking to one of my old uni mates about 3-4 years ago, he was telling me he's the head of department of a school over on the other side of Brizzy, and he used to call it the Ken circle, and he used to use it. His name's Ken. That's probably why he did it. He's silly if he called himself something else. But he used to take him outside with a piece of long strip of garden hose, and he'd use the garden hose to do this activity. But it's a really interesting one, and we're going to understand that radians are really, they're just a different way of measuring angles. I say to the kiddies, you're watching telly and someone's on the telly and says, I'm 6'2". How tall are they? And they've got a pretty good understanding that 6'2" is someone, who's pretty tall. What do we say in Australia? I'm 187 centimetres tall. We just use different units to explain the same thing. As 1 foot is different from 1 metre or 1 centimetre. So just using different units, and we don't want to sort of overcomplicate something that doesn't need to be. Don't overteach something. So then we go into, so that's what we're going to do in the tutorial. And then from there, I think it's a beautiful little segue into the area, length and sector area. If you look back at the syllabus, that's what it says that we have to do. But it's really interesting when you go to the literature and you have a look at, I say literature in terms of textbooks that are available for students and teachers to use in the classroom. The syllabus is quite explicit. It says length, arc length and sector area. So we need to get into, the language. Is it a minor sector? Is it a major sector? Is it a minor arc or a major arc? The angle is subtended at the centre. So there's a lot of language that happens with that. Language that probably kids are not familiar with. So you have to make sure that you're quite strong in that language and the literature of it. Again, if you look in any work that's done with Hattie, he likes his visible learning, and so again, I have that up on the wall there. We talk about a minor arc and a major arc and a minor sector and a major sector. And going from radians into sector area and arc length, there's a nice little easier sort of, again, on their formula sheet, a nice little set of formulae that we can use to determine what the arc length and sector area are. Whether it's minor or major, it doesn't matter. The thing that I do notice though when I'm looking through resource materials that I want to use to supplement learning for kids, or maybe looking for extra questions in textbooks for exams, then I don't know why, but we have somehow some people get into chord length. And so, for example, in this particular picture here, what's the length of chord AC? While there's nothing wrong with that, what you're doing there is that complex thing, because what you've got to do is have a look at the angle at the centre there. Then you've got to look at the triangle using the trigonometry done from right angle triangles or non-right angle triangles. There's a bit of geometry you've got to do there. It doesn't fit into arc length and sector area, the length of a chord, but you'll find it somehow in lots and lots and lots of textbooks. So just be aware that when you're setting questions for kids, is this covering the syllabus or is this not covering the syllabus? Are we going to put that into an exam or are we not going to put it into an exam? And again, if you talk about context and stuff, you might be looking at around sports time, for example, and you're looking at arc length and for example, when you're looking at things like discus throw and shot put and javelin and anything like that. Something that kids can actually just engage in very quickly. It's not the only thing, but it's just an example of one. So then we move on to unit circle, and again, this is something that schools are looking to do in Year 10 now. It is part of the 10A syllabus. You can find it there. But the unit circle, how do we actually understand what the unit circle is? And most kids, the first thing they'll talk about is the sine, cos and tan. No, it's a circle with a radius 1. That's a unit circle. So the unit circle, radius 1, we've got a point PXY on that circle there, and as we rotate that point P anywhere on that circle there, we can determine the coordinates of that point by the fact that the radius is equal to 1 and the angle between the radius and the x-axis is angle theta. So just be very careful there when we say the angle. We're talking about the angle between that radius as that point P rotates around the circle, the angle between it and the positive x-axis. So in terms of unit circle there, again, what I'd be doing, this is a really nice, beautiful hands-on approach. If you want to have a look at, click on some of these, you can't click on them, but maybe look at where you might find them. There's a couple of good examples there on how we can use the unit circle in terms of exact values. The little hand trick there, 0, pi on 3, pi on 4, pi on 6, no, pi on 6, pi on, I don't even do it myself, the kids do it. 0, pi on 6, pi on 4, pi on 3 and pi on 2. They draw on their hands, and from there they can actually work out how many fingers are up and down, whether the sine of pi on 6 is equal to this or equal to that. I was taught a totally different way. We didn't have a left hand when I was at school. We used to draw a triangle, and from there we'd actually work out what those exact values were. But the kids loved this little hand trick. When it was shown to me a few years ago, I went, get out of town. That's just not fair. That's just not fair. It's not allowable. Not allowed to do it. It's too smart. And then when you get to supervising the exams, you see them playing with their fingers and you go, what are they doing? Stairway to Heaven or something, you know? No, it's a pretty cool little trick. And that's really all they need to know, just what those exact values are. And those exact values are really important also for when those kiddies are also doing their specialist maths. So just bear that in mind. That's something that I know the specialist maths teachers always say, kids don't understand the exact values. So it's something you can just keep working on, and that's just a little trick there, that little, the left-hand rule. The other one is about introducing radians there. You can have a look at it. We're going to do it in the tutorial there. But what is a radian? And I use paper cups to do it. And, you know, getting a piece of string and tying knots in it and doing all sorts of fancy stuff. And it actually gets in the kid's mind what these things called radians actually are. When I get an answer of, you know, 1.2 radians, oh, okay, I understand 1 radian is about that, 1.2. Yeah, that's about right. That sounds good. The other thing too, I think what it does do when you do the activity with the paper cups and you have a look at the, very similar to what the manipulative link there we got on YouTube is that, again, what it does, it allows the students to develop the idea of the conversion between what pi on 4, 45 degrees, that sits there, right? So there's pi on 2 and there's 3 pi on, and so when they're looking at that, you can say, well, what about if I put here, you know, x radians? What is the angle measure for that? We'll put that down. So what I'm going to challenge you guys to do, and hopefully Ben will do with you, is give you some paper cups with some written on it, some angles, and what you've got to do is put on the unit circle where you think that angle is approximately. We're not going to get a protractor out and measure exactly where those angles are. So we'll just get an idea of where it's roughly going to be. So where is pi on 6? Where's 7 pi on 6? Put that down on the unit circle where you think 7 pi on 6 is. How do you articulate where you think that is? And it's good to stand back and watch the fun, because it's like feeding sharks. It's good fun, and the thing that get out of it is, one, it's actually enjoyable for the kids, but two, it's amazing how that deeper learning happens.